Good evening, and I'd like to congratulate you first of all on this event. I think that this topic is extremely important for our community, not only for patients, but also for their family members. And we are seeing an increasing interest in Gaucher's disease because of the link with Parkinson's. We're seeing many new companies come into the space. Companies that have been interested in Gaucher are now looking at Parkinson's and vice versa. So it's an exciting time in terms of research and knowledge, which hopefully will support our community going forward and mean that where people find themselves with Parkinson's, that there is potential therapies. So thank you very much.
Our speakers today will be Professor Hughes, who is Professor of Experimental Hematology at University College London, hematology consultant at the Royal Free Hospital, and chairman of the European Working Group on Gaucher Disease. And she will give us an update on the latest therapeutic strategies for Gaucher disease. We will then have Professor Schapira, who is head of the Department of Clinical and Movement Neurosciences at UCL and Professor of Neurology at the Royal Free Hospital and National Hospital for Neurology and Neurosurgery, and Principal Investigator of Rapsodi and PD Frontline. Professor Schapira will talk about the link between GBA mutations and Parkinson. And then we will have some members of the Rapsodi study team, Chiao Lee, who is in charge of the laboratory analysis for Rapsodi and PD Frontline. She has a background in biochemistry and has studied molecular and cellular biosciences at Imperial College London. She will explain the pattern of inheritance of GBA mutations and other Parkinson-causing mutations. Then we will have Abigail Higgins, who is study coordinator for Rapsodi and head of recruitment for the study. She studied neuroscience at King's College London and will talk to us about the Rapsodi study and how to take part. And finally, we will have Sofia Koletsi, who is study coordinator for PD Frontline, which is another study that you'll learn about today, and who has a background in clinical neuropsychiatry from King's College London, and she will outline the PD Frontline study. So we are ready to start, and the first speaker is Professor Hughes.
So thank you, Marco. Thank you, Tanya. It's lovely to be able to be with you virtually tonight. I can see there's lots of people that I know on the list of participants, and it's really great to meet you, even if it's just virtually in this way, and I hope you're all well at this very difficult time. So Marco's asked me to talk about emerging treatments for Gaucher disease. So what I'm going to do is briefly describe some of the challenges of the therapy that we currently have for Gaucher, and then step through some of the new developments and things which are currently in clinical trial, including some things which are still really quite a long way from coming into clinical practice, but it will give you a flavour of the sort of things which are being thought about and which might also address some of the neurological aspects of Gaucher disease and therefore may be relevant to our discussion in relation to Parkinson's disease. So I'm sure that not everybody on the call actually is aware of Gaucher or has Gaucher. So just very briefly, Gaucher disease is a rare metabolic disorder. It's probably not as rare as we think. We know that there is still lack of awareness of Gaucher in some areas and probably underdiagnosis. And it's due to inheritance of a deficient or missing enzyme, which would normally break down some sugar molecules called glucosyl ceramide into smaller molecules. And because that enzyme, beta-glucosidase, is missing, it means that these molecules that would normally be broken down, these substances, fatty sugary substances, build up in various cells in the body, including cells in the bone marrow, in the long bones, in the liver and spleen and other organs, and cause a whole range of other problems. And you can see here these purple cells filled up with this fatty sugary material. And that results in bone pain for people, large livers and spleens, low blood counts, deformities or misshapen bones, and a lot of trouble in terms of things like fractures, the bone pain and bone thinning. And in some patients, there is a more severe type of the condition where the enzyme activity is very low indeed, and that also causes neurological features or features affecting the brain and nervous system. And through the work of Professor Schapira and colleagues, we know that there is a relationship between Gaucher disease, or being a carrier for Gaucher disease, and Parkinson's. So our current treatment for the last 30 years has largely revolved around administration of the missing enzyme. It's given intravenously every 2 weeks, and there's several forms of the enzyme have been developed. But there are some challenges associated with enzyme therapy. And the first one is that because enzyme is a large molecule, it doesn't actually penetrate into the brain. There's this entity around the brain that he called the blood-brain barrier, and that effectively keeps toxins and bacteria, products that we wouldn't want to go into the brain out. But a side effect of that is it also keeps enzyme out of the brain. So one challenge for us is to develop a treatment that would get inside of the brain. In the same way that the brain can be challenging, then also getting appropriate treatment into the bone is also challenging, and also reversing some of those long-term effects that have been going on in the bone can be very difficult. We can say the same thing for the lung as well. For some reason, the lung is quite a protected site for enzyme. It's rarely severely affected in Gaucher, but we do find that some people who've got the sort of Gaucher that mainly affects the liver and spleen also have lung problems, and it's even more common in the neurological forms of Gaucher, the more severe forms. And finally, patients sometimes have enlarged lymph nodes, and these can cause problems in the abdomen. They can cause congestion there, which means that it can cause bloating and difficulty with absorption, and sometimes can get confused with other more sinister conditions. And again, it can be very difficult to get enzyme into some of these areas. So enzyme replacement is a really great therapy for many of the systemic or body effects of Gaucher disease. But those are some of the challenges: delivery to the site of the pathology, getting into the brain, sometimes generation of antibodies, and sometimes, because it's delivered intravenously, also the fact that it has to go into the vein and venous access. So it's been important to think about development of other treatments. And we have had some success over the last 10 years or so in developing oral treatments, the first of which has been called substrate reduction therapy. And the idea here is that instead of breaking down the substrate, the glucosyl ceramide that it's built up, we prevent it from building up by blocking its production. And this is a biochemical pathway, but you can also understand this by thinking about a bath or a funnel being filled up with fluid. And it will retain a steady state if the production is the same as the amount flowing out. If the production is at a normal rate, but it's not cleared, then it will build up, and this is the disease state. An enzyme replacement therapy would be increasing the destruction of the amount of the substrate here. The way substrate reduction therapy works is to block that production. So even if you've got a very low level of elimination, you still don't have an increased amount of substrate building up. So it's blocking that production mechanism. And there are 2 drugs now for Gaucher disease which are effective as substrate reduction therapies. Miglustat, which we've had now for 16 years, but has got some difficulties in terms of side effects, and also perhaps doesn't work in patients who are more severely affected. But also iliglustat, which is a newer molecule and seems to be more effective and on the whole better tolerated. So for some patients, this is a appropriate oral alternative. There are some caveats to that, which I won't go into now. It's not appropriate for everybody, depending what other problems they might have. Unfortunately, one of the problems for oligostat is that it doesn't effectively get into the brain, so it's not a good treatment for neuronopathic Gaucher disease, or the neurological form of Gaucher. So we do have a study ongoing at the moment looking at another form of substrate reduction called venglustat in combination with enzyme replacement therapy to try to assess whether this new form of substrate reduction venglustat is actually effective. And at our virtual meeting about 3 weeks ago now for the EWGDD, we saw some very encouraging results for venglustat in combination with enzyme therapy. Another possible oral treatment is known as pharmacological chaperone therapy. And the way this works is for a small, usually sugar molecule, but it could be another molecule, to bind to the faulty enzyme, help it fold properly and become functional again. And one molecule in Gaucher that is being trialled for this in various places is called ambroxol, and here's a picture of it. Because ambroxol is very small, it can cross the blood-brain barrier and so may also be an effective treatment for some of the neurological manifestations of Gaucher disease. And again, there are really encouraging results for this emerging from some very small clinical trials as yet in various parts of the world. Another form of treatment is potentially harnessing something which occurs in nature called heat shock proteins. Now, heat shock proteins are a natural system that help other proteins to work. So if the body is subject to some kind of toxicity or high temperature, hence the name, then these little molecules called heat shock proteins can protect the underlying enzyme or protein and to help it to fold and restore its function. So a molecule called arimoclomol is being worked up and investigated for Gaucher to see if this is a natural chaperone which can help the folding of the digestive enzyme to help it be processed normally within the cell. And so this company, Orphazyme, are looking at arimoclomol to see whether it will work in that area. So they're looking to see whether it can actually also cross the blood-brain barrier and also have potential effects in neurological disorders. Another idea is to see whether we can disguise enzyme so that the body doesn't see it in the same way, so that it therefore doesn't cause antibodies and also potentially can get into the brain. So by encapsulating the enzyme into something called an exosome, then it may be able to get through into the brain and treat patients with neurological symptoms or getting to those other parts of the body that can be a challenge. So the things we were talking about in terms of lung and bone and lymph nodes. And this is actually an exosome. Now, I showed this a long time before we had problems with coronavirus, but now it looks, unfortunately, a little bit like coronavirus, but it is actually a manufactured entity called an exosome. And finally, gene therapy. So this is something that we are working on for some disorders that are all free. Actually, one of Gaucher's sister disorders called Fabry disease, we have already a gene therapy program and have started to treat people. And in time, we will extend this into Gaucher. So the concept here is, can we fix the broken gene? Can we give a patient a new gene which will replace the missing gene and thereby manufacture the protein? So unfortunately, we can't just inject DNA into patients. It would straight away be cleared away by the body as a foreign material. So what we do with gene therapy is we use a virus like a little mini spaceship. And these are some pictures of a virus. I mean, this one is quite like, looks like a spaceship, but we can strip out all of the bad part of the virus, add to it the DNA for the Gaucher gene, give it to the patient, and thereby enable the production of enzymes. So we inject the virus with a little bit of DNA inside, and in it goes, it lives in the liver and produces enzyme. And I think this is now becoming a viable possibility for patients with Gaucher disease. And there's quite a lot of trial work being done, again, internationally, in gene therapy for Gaucher. So that's a little canter through some of the emerging treatments. So Gaucher's got many features, and not all of them are addressed by a single therapy. Enzyme replacement and the new substrate reductions are really effective treatments for a lot of the problems with Gaucher disease outside of the brain. But it's really important that we look to try to develop new treatments for patients with some of those hard to get at areas, including the brain and the bones and lungs and so on. So thank you very much for listening and for attending tonight.
Next speaker is Professor Schapira, and he will talk to us about the link between GBA mutations and Parkinson.
Thank you very much, Marco, and thank you, Derralynn, for an excellent review of treatments of Gaucher disease. So I'm taking things off on a slightly different route at the moment, but I'm sure they'll all come back together when we take the discussion and questions. So it's the link between the gene abnormality that causes Gaucher disease and that link with Parkinson disease. And this has really only gained significant attention over the past 10 years or so. And it's leading to a real acceleration of our understanding of Parkinson's disease and to some extent Gaucher disease, but also, as Derralynn mentioned, an acceleration of potential treatments for both of these potentially into clinical trial. So let me talk a little bit about the link between the Gaucher gene, GBA, and Parkinson's disease. So people who have Gaucher disease and also people who are carriers of the GBA gene abnormality, but don't actually have Gaucher disease because they only have one dose of the abnormal gene, all of these people are at risk of Gaucher disease, probably to a similar level, even though the Gaucher people have two abnormal genes and the carriers only one. Their risk of Parkinson's disease is about the same, but that risk is small. It's estimated that about 1 in 3 to 1 in 5 of those people with an abnormal GBA gene will develop some features of Parkinson's disease by the age of 80. So they are a minority, but nevertheless, a significant number that attracts our attention. On the other hand, if you look at people with Parkinson's disease and then investigate them for how many have abnormalities of their GBA gene, well, we find that about 10 to 15% of them have such abnormalities. And this means that abnormalities of the GBA gene are the most common association with Parkinson's disease. So this is obviously a very important observation in order to help us try and understand the link between GBA and Parkinson's disease, and importantly, to try and understand how we can develop some treatments. So the future, and what does that hold? Well, here's a mixture of things that are in the future, but some which we already have, in fact. So we already have a very good test for the GBA gene, and such testing has been around for a while, but has now become much more refined and accurate. So we can test people very easily, for instance, simply with a saliva sample. New treatments for GBA associated with Parkinson's disease are now being tested, and Derralynn touched on some of these. One of them is the ambroxol drug that Derralynn mentioned. This drug has been around for quite some time as a cough linctus, but it actually acts on the product of the GBA gene that's deficient in Gaucher disease and increases its activity. So the idea was that this drug, because it increases the activity of the defective enzyme, may be beneficial in Parkinson disease. So an ambroxol trial in Parkinson disease patients was completed last year. And these were patients, it was a relatively small study, but the patients were divided into those who had Parkinson with a mutation of the GBA gene and those who didn't. And the purpose of the trial was to see if ambroxol was able to get into the brain, and Derralynn pointed out that there is this barrier between the brain and the rest of the body to help protect the brain. So we need to get through that barrier in order to get to where we need the drug to work for Parkinson's disease. And the second purpose of the trial was to see if the drug was able to interact directly and increase the activity of the GBA enzyme. And I'm pleased to say that the drug succeeded in both those aims. So it was clearly able to get into the brain and also clearly able to increase the activity and level of the GBA enzyme. It was also shown to be quite safe at relatively high dose for a relatively long duration of 6 months. So this drug ambroxol is now going forward for more detailed clinical trials to see if it's able to affect the course of Parkinson's disease, to slow it down. And of course, if it is able to do that, then we could see if it could potentially prevent people getting Parkinson's disease who might carry the GBA gene. Another drug which Derralynn mentioned, venglustat, is also in clinical trial. This is the substrate inhibitor or reduction therapy. And this is also now in trial for Parkinson's disease, but the results are not yet published. So there are these two drugs, but numerous other types of drugs, including gene therapy, which are now being looked at for GBA and Parkinson's disease. What we need to do is to understand the link between GBA gene abnormalities and Parkinson's disease more clearly in order for us to develop more specific treatment. So we need to understand exactly how the GBA gene is capable of producing Parkinson's disease and what it is about some of the people with GBA gene abnormalities that they seem more susceptible to develop Parkinson's. So we need help to understand that link. We need help to test the new treatments that are coming online, like ambroxol, which will start its new trial in GBA and Parkinson's disease later this year. But there'll be other treatments that also require help to test whether they work or not. So as part of that, we are offering people the opportunity to be tested for their GBA gene so that when the time comes in the not too distant future, they will be able to participate if they wish in clinical trials specifically for those with GBA gene abnormalities. So that's our moniker of Get Trial Ready.
Next in line, we have Chiao.
My name is Chiao, and I'll be talking to you about genotyping for GBA mutations and LRRK2, which is another mutation that Rapsodi also looks for. So everyone has 2 copies of the GBA gene. One is inherited from your mother and one is from your father. People who have 1 mutated GBA copy are known as healthy carriers because 1 single copy will not cause Gaucher disease. People need 2 mutated copies of GBA to have Gaucher disease. GBA encodes an enzyme called glucocerebrosidase. People with 1 mutated copy of GBA and people with 2 mutated copies both share a small increase in risk for developing Parkinson disease over their lifetime. However, most GBA mutation carriers will not develop Parkinson's disease in their lifetime. And how is GBA inherited? Well, let's say we have a mother that has one mutated GBA copy in red and one non-mutated GBA copy in blue, and the father has the same. Then there is a 25% chance that the child will have two mutated GBA copies and therefore have Gaucher disease. There is a 25% chance that the child will have no GBA mutations and be healthy. And then there is a 50% chance on the top right corner and the bottom left that their child will have one mutated GBA copy and one non-mutated GBA copy, meaning that they are a carrier. They will not have Gaucher disease, but they will have an increased risk of developing Parkinson's. GBA mutations decrease the activity of the enzyme glucocerebrosidase in the brain, and this altered enzymatic activity has been found in the brains of people with Parkinson with no known genetic causes. This means that GBA is implicated not only in GBA-associated Parkinson disease, but also for the wider community of people, all affected by Parkinson disease. LRRK2 is another gene that we screen for, and it codes an enzyme called leucine-rich repeat kinase 2. Over 50 different LRRK2 mutations have been implicated in Parkinson's disease. And Rapsodi screens for the LRRK2 G2019S mutation, which is the most common mutation, and it's a very strong risk factor for Parkinson's disease. And only one mutated LRRK2 copy is enough to increase the risk. LRRK2 mutations, however, are extremely rare and only accounts for around 2% of sporadic PD cases. And why do we need your help? Well, we want to know why single and double GBA mutation carriers share a similar risk for developing Parkinson's disease. Therefore, family participation is extremely important to allow us to incorporate people with both single and double GBA mutations into our research. So this means that not only you are vital to our research, but also your extended family members as well. And your contributions will help scientists develop better treatments for Parkinson's disease and more efficient diagnostic procedures. Now, I'll talk briefly about how you can get involved, but then Abby, who will speak after me, will go into the details. So when you sign up at rapsodistudy.com, we'll mail you a DNA collection kit. You then spit in the tube and mail it back to us, simple as that. And then we'll sequence your DNA for GBA and LRRK2 mutations. We can then let you know your results if you want to, but you do not have to know your results. When you choose to want to know your results, we will also offer free over-the-phone genetic counselling, and your data will be securely stored in our database at all times. Thank you for listening.
Now, for the last 10 minutes of the webinar, we will have Abigail talking about the Rapsodi study, and then Sofia talking about the PD Frontline studies.
As Marco mentioned, I'll be talking about the Rapsodi study today. I know that some of you are already familiar with it and some maybe not so much, so hopefully there'll be something for everyone in this talk. I'll be talking about our rationale and the aims behind our study, a little bit about where we are with our recruitment process and what this looks like for the future of our study, why family participation is so important. I'll talk a little bit about genotyping, but not too much, as Chiao has already gone over this in quite a bit of detail. I'll talk to you about what participation involves and how you and your family members can get involved if you're interested. So, as Professor Schapira and Chiao have already mentioned, GBA mutations have emerged within recent years as some of the most important known risk factors for Parkinson's disease. And this is true both for double GBA mutations, which cause Gaucher disease, and for those healthy carriers with those single GBA mutations. But something that's important to note is that it's only a small proportion of individuals with GBA mutations who will go on to develop Parkinson's disease. So on this basis, the Rapsodi study has figured that the most powerful way that we can study this link between GBA mutations and Parkinson's disease is to follow a large enough group of individuals with GBA mutations over time, and to really understand why it is that that minority goes on to develop Parkinson's disease. So if we can understand this pattern of disease development, we can create better diagnostic procedures, earlier diagnostic procedures, and really intervene before Parkinson's disease can develop. So what we look at in the Rapsodi study, we look at some of the most preliminary, some of the earliest signs and symptoms that are associated with Parkinson's disease. Now, as I say, they're associated, they're not necessarily indicative of. So we look at quite a range of signs and symptoms. And these are inclusive of things like memory deficits, something called bradykinesia, which is like a slowing of movements. We look at any kind of smell loss and any sleep disturbances that people might have. So where we are with our work so far, we've recruited just over 800 participants. We had ethical approval for up to 10,000, but more realistically, we're aiming in the short term to get around 1,000 participants. And the way that we're doing this is we're working with Gaucher disease clinics across the UK. The reason that we do it like this is because if we were to screen the general population for GBA mutations, it would be a bit like looking for a needle in a haystack, whereas we know that individuals with Gaucher disease have those 2 GBA mutations. But the issue with this sort of recruitment strategy, if you will, is that we all know, and I know that a lot of you will be aware, that Gaucher disease is a rare disease. So even if everyone who is aware that they have Gaucher disease in the UK got involved in Rapsodi or wanted to, we probably still wouldn't reach those crucial numbers that we need to understand this sort of link between GBA and Parkinson's. The other issue is that we want to look at these people with single copies of GBA mutations, these healthy carriers that we've mentioned, as well as people with Gaucher disease. And many people who have single GBA mutations, if they aren't related to someone with Gaucher disease or someone with GBA-associated Parkinson's, they don't know that they have these mutations and they can't really self-refer to us. So the only way for us to sort of identify both individuals with Gaucher disease who have these double mutations and individuals with these single mutations is to talk to people in Gaucher's clinics and get them involved in Rapsodi, individuals with Gaucher's disease, and to go through their family members to try and find people with single GBA mutations, because they are much more likely to have these single GBA mutations if you're related to someone with Gaucher's disease than the general population. And to sort of visualize what I mean by this a little bit better, as Chiao mentioned earlier, we all have sort of 2 copies of every gene in our genome, and we inherit one from our mother and one from our father. So in this graph here, we sort of can see what would happen if a mother who has a single mutated copy of a GBA mutation, as denoted by that sort of squiggly blue alpha helix at the top, and a single non-mutated copy, as denoted by the sort of black double alpha helix next to it, was to have a child with a father who is depicted in the vertical plane with the same situation. He's got a single mutated copy of GBA and a single unmutated copy of GBA. So every time that these 2 people had a child, they would have a 25% chance of inheriting both mutated copies of GBA and therefore having Gaucher's disease. Alternatively, there's a 50% chance that these children would have a single mutated copy of GBA, so they would be healthy carriers much like their parents. And lastly, there's a 25% chance that their child would not have either a mutated copy of GBA, they just have 2 unmutated copies, sorry. So yeah, and I wanted to show you this because it's a bit of a snapshot of why getting family participation is so important in the Rapsodi study, because we can see these strong patterns of inheritance of the GBA mutations within families affected by Gaucher's disease. And it's not just true for parent-child sibling relationships, it's also true for nieces, nephews, uncles, aunts. And we're really interested in recruiting anyone over the age of 18 who is a blood relative of someone with a GBA mutation or 2 GBA mutations. Because like I said earlier, that slight increase in risk for developing Parkinson's disease is true for these healthy carriers and individuals with Gaucher's disease. But something that's really important to note about the Rapsodi study is we know that genetic mutations are an incredibly personal topic. And some people who have these sort of mutations within their family, they may not want to know very much about it. They might want to focus their attentions elsewhere, and that's perfectly fine. Whereas other people might be very interested in knowing everything they possibly can and getting really involved in research, and that's also okay. So we will never contact your relatives without your permission. We will always go to you first and say, is it appropriate for us to contact anyone? Who is it appropriate for us to contact, and how can we best approach them? So a little bit about our genotyping process. Like Chiao said, we'll send you out a tube in the post and you spit in it. You put it in an envelope that we give to you. It's a free post envelope that we send out, and you just put it back in the mail to us. And from this saliva sample that you provide for us, we look for 2 classes of genetic mutations. The first is GBA mutations. So there are many different known GBA mutations, and we screen the whole gene. So we basically will identify any potential GBA mutation that you might have, and they all have their own different characteristics. But this is how we can identify these carriers who are associated with this slight increase in Parkinson's disease risk. We also look for the other mutation that Chiao mentioned, which is the LRRK2G2019S mutation. And the reason that we look for this is that it has a very strong implication for Parkinson's disease. But something that's important to note here is that it's not associated with GBA. The reason that we look for it is because we want to know that any sort of Parkinsonism or any signs or symptoms of Parkinson's disease that we might see in an individual with GBA mutations can't be attributed to any other sort of genetic factors. And this is quite an important one for us to look at. So Rapsodi is an online study. It's once a year, so it's an annual study. In your first year, you log on and it takes around 45 to 60 minutes. We ask you a series of questions about you, things that are pertinent to our research and our data analysis. So those are things like gender and age. We then also look at those early signs and symptoms of Parkinson's disease, like I mentioned before. So we do a keyboard tapping test to look at the sort of speed of your movements. We then do questionnaires that will look at things like sleep disturbances, and we test your memory function via a bunch of cognitive tasks, which are like mini online video games. And these are quite novel tasks, and not everyone really understands on the spot what they're doing the first time. So what we do is we repeat these cognitive tasks 1 week after you first complete them, just so that we can sort of catch up and be like, oh, this is what it meant rather than this. And so we can sort of get your true score, if you like. Once these are sent out to you, once these are completed, we send out to you a smell test and a saliva sample kit. So I've already talked about the saliva sample kit, but the smell test is essentially a series of scratch and sniff booklets, 4 of them. You scratch a tiny little panel on the book, you sniff it, and you're given a series of 4 different answers, and you say which smell it's most likely to be. And you send that back to us free post in the same envelope that you do your saliva sample kit. And that first year really gives us your baseline functioning. It tells us how you're performing when you first enroll in the Rapsodi study, and it gives us that benchmark to sort of compare you to when we go on and progress through the years. And so from year 2 plus, it's a very similar story. It will take about 45 to 60 minutes online again. You log in, we ask you about you just to see if anything's changed. We do the keyboard tapping, the questionnaires, the cognitive tasks. What you might notice is we don't repeat the cognitive tasks again, because by then we feel like we've established the instructions. We also will never send you another saliva sample kit, because once you're genotyped, that's it, it won't change. But we will send you another smell test kit. And we do that every other year so that we can really tease out those differences that some people might experience in their smell function. So we'll send those out every 3rd year, the 5th year, the 7th year, every odd year, but not in years 2, 4, and 6, if you will. So all you need to take part in the Rapsodi study is a computer with a physical keyboard. You need a physical keyboard so that you can do that keyboard tapping test that we talked about. You will need internet access to get online onto our portal, and you'll need an email address that we can set you up with so that we can email you once a year and say, your Rapsodi study is ready to complete. Please log on, and you've got 60 days to complete that in. So we are an online study, and we like to maintain a largely online presence. So if you're interested, you want a little bit more information, but you don't want to talk to a team member, that's fine. Please visit our study portal, rapsodistudy.com. If you would like to talk to a team member, perhaps you're interested in getting enrolled, you have a more specific question, or you have a family member you'd like to refer to us, please don't hesitate to email us at rapsodi@ucl.ac.uk. We've got Twitter, we've got Facebook, we've got Instagram. We also have a landline for the office. Unfortunately, due to COVID-19, we're not in the office at the moment. But if you would like to talk to someone over the phone, that's perfectly fine. Just email us with a phone number and your name and a date and time that's good for you, and we'll give you a call.
The last presentation will be from Sofia, who will talk about the PD Frontline study. PD Frontline is a sister study to Rapsodi, and we designed it specifically for people that already have a diagnosis of Parkinson's disease.
Right, so as Marco just said, I'm Sofia. I am the study coordinator for PD Frontline. So PD Frontline is a sister study of Rapsodi, and it's also an online study offering genetic testing for people that currently have a diagnosis of Parkinson's, with the prospect of referring them to appropriate clinical trials and other observational research studies that they might be eligible for. So much like Rapsodi, PD Frontline offers the same genetic testing for the 2 genes linked to Parkinson's that my colleagues Abby and Chiao have already covered, the GBA and the LRRK2 gene. And I suppose the main premise for the creation of PD Frontline lies in the fact that many of the drugs that are currently being developed for Parkinson's are targeted at specific genes that are known to influence how the disease progresses. And this, of course, was also reinforced after a recent publication of the Ambroxol trial, which Professor Schapira already covered in his talk. But essentially, it just highlighted that how strong the prospects for research into GBA Parkinson's are. And this is exactly why we feel like it's so important for researchers to be able to reach out and identify a large group of people with Parkinson's, with and without genetic mutations, so that we can then enroll them into clinical trials that test if and how well these drugs work, and also see if there are any differences between the groups of those with and without genetic mutations. And essentially, that's exactly what PD Frontline offers. It's a one-time deal, if you will. Anyone with a current diagnosis of Parkinson's living in the UK can simply visit our website at pdfrontline.com. They then have to register their details. They can read and sign the consent form and answer a few short questions. At that point, as I'm pretty sure you're all used to it by now, we would send a saliva collection kit at home, which they can then send back to us in prepaid packaging. So that is all the participant involvement required. After that, once we complete our DNA sequencing and we have the genetic test results ready, we would communicate those back to the participants and provide genetic counseling where appropriate and where needed. After which point we would then be able to contact participants in the future again and make them aware of new clinical trials and other studies that they might be eligible and they might wish to take part in. So once again, pardon me, just to reiterate how important participant engagement is and to clarify the two enrollment pathways. For anyone currently with a diagnosis for Parkinson's, they can visit pdfrontline.com to find out more about our research and perhaps register if they're interested. And although it's already been covered, again, for anyone that is a known GBA carrier or related to a GBA carrier or someone with Gaucher disease, they can visit our website at rapsodistudy.com, find out more information there and register if they're interested. So I think I will stop there. Thank you everyone for listening.
I would like to thank again the Gaucher Association for their incredible support for our study and in general for patients with Gaucher disease. I would like to also thank all the speakers, and in particular Professor Hughes, who was very appreciated at the event we organized last year, and all participants asked us to invite her more often. And of course, Professor Schapira, who is PI of the study, but is also a source of invaluable knowledge, as always. Thank you very much to everybody who attended, and we'll update you with news from both studies periodically. Thank you. Goodbye.